This is our 5 to 10 minute review of the skin. It's not part of our bone lecture, so you don't have to watch it if you don't want to. However, some students like going over the previous lesson, so I'll continue that online. So, the skin is made up of two regions. We have up here the epidermis, and then this whole area is the dermis. So according to highlight tool, this is the epidermis. I think it invaded part of the dermis right there. But this green region would be the epidermis. Then all of this down here would be the dermis. Now if we scroll down to the bottom, we have this tissue. What kind of tissue is that first? That's right, it's adipose connective tissue. And this is all the hypodermis down here, which is subcutaneous fat. It's not considered part of the skin proper. So, skin has an epidermis, which is from here all the way up to here, a palpary dermis, which is this area right here, and a reticular dermis, which would be downwards a little bit. The epidermis is made up of 4 or 5 layers. This is thick skin. I know it's thick skin because I have this layer right here, which is the stratum lucidum, and it's only found in thick skin, which is in the palms of your hands, palmar region, and the bottoms of your feet, the pedis region. Now, other regions, this first region is only 1 cell layer thick. That is the stratum basale. Think of Hermione Granger correcting Ron for the upteenth time on how to cast a spell. That's how you say it. Now notice, it's blacker. That's due to the melanocytes and the stain they used for this slide. Now here, you have the stratum spinosum. Notice how the cells are a different color here. So when I point to the stratum basale on the test, it is going to be only this one region. And just because of this slide being taken at about scanning, I think it was like 40 power, you can't really tell. There, I tried to darken it a little bit, but you can't really see the cells. Now, the stratum spinosum. That is this whole region, including what's going down into the epidermal ridges. That is keratinocytes. And what do keratinocytes make? That's right, they make keratin. So, highlight everything just failed miserably. So, this is the keratin, or keratinocytes, and they're making keratin. And it goes down here. Eek! I flunked coloring in, can you tell? Now, if we go up, we see this very, 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 very faint, darker region right here. That is the strata granulosa, or granulosum. Again, Hermione Granger. See how it's darker? So here are keratinocytes making keratin. Here is our darker layer, and it's granular. Those are going to be making a glycolipid, and that's going to help waterproof the skin. And unfortunately, the combination between the keratin and the glycolipid, the cells die. Your book says it's the keratin that forces all the water out. So here is the strata lucidum. It's only in thick skin. And then we have the strata corneum, which is this tough, dead cells, shingle-like that are, oh look, they're falling off. Now, this is the top part of the epidermis, or the dermis. It's part of the palpary dermis. It's made up of areolar connective tissue. And it has these Meissner's corpuscles in it. So that would be a Meissner's corpuscle. So you need to know the palpary dermis is areolar connective tissue, and it has Meissner's corpuscles. Now, for the dermis, you need to know the epidermis, you need to know what's going on in each level. I've mentioned that several times, I believe. If not, you need to know what happens in each layer of the epidermis. So back to this slide. The dermis is actually made up of 2 layers as well. We have this right here. And look how thin it is. I'm really just filling in the whole thing. That is the palpary dermis. That is what is made of the areolar connective tissue. And we have the Meissner's corpuscle. So there might be a Meissner's corpuscle there. Now, all the rest of that, do you recognize that tissue? I really hope you do. It is dense, irregular connective tissue. And that dense, irregular connective tissue makes up the reticular dermis. So we have some cool structures. This right here, you're going to get to learn is muscle tissue. Yes, pink on pink. It looks great. In the face-to-face class, the only pencils we use in lab are the pink and the purple. Sometimes the brown. So this is the erector pili muscle. It causes this hair follicle to become erect. Now, the hair follicle, here's another hair follicle, is going to have several parts. Look how far down I had to go. That is the bulb. That is going to produce new parts of hair. And then you see here, that is actually part of the epidermis coming all the way down to wrap it. Then we have the root. The root is under the hair. And if we scroll up, the root goes up, and the slides are never made so you have the whole root. So this root is going deeper in. We have more of that root going out. And that first root would come out here. Now, sitting on the hair follicle is this gland right here. There's another one attached to this hair follicle. This is probably on a hair follicle that was deeper in. Here's another one. Those are all sebaceous glands. They produce sebum. And that's oil that helps lubricate your skin. I have a gross story. My wife went walking with her friend, and her friend has a 13-year-old son, 14-year-old son. His hair is making so much oil, he has to actually wash his hair twice a day. That's the sebum. It's controlled by hormones and starts at puberty. I have a few more years for my kids. Now this gland right here is a tightly coiled gland. That is an eccrine sweat gland. Eccrine sweat glands have ducts, which isn't on the slide, that go all the way to the surface. And it produces sweat that's mostly water. This is an apocrine gland. Its lumen is a lot bigger. And this slide is titled Apocrine Gland Low Power. So they're actually these humongous glands, stratified tissue right there. And they're going to make a sweat that is high in lipids and high in protein. They are thought to act as pheromones. So this is a Google Images picture. This is the eccrine gland, so smaller lumens, the apocrine gland wider. The eccrine glands are usually deeper into the skin as well. And the difference is this sweat is mostly water, duct goes to the skin. This sweat is viscous, proteins and lipids, and its duct goes to the hair follicle. So again, for the glands, you need to know what it makes and where the duct goes. The last gland we talked about, mammary glands, they're in the mammary region. I think you guys know where that is. And they produce milk. So here's another Google image picture comparing the three. The sebaceous gland is sitting on the hair follicle. The apocrine gland tends to be deep. And the eccrine gland is about middle of the dermis, and it's more tightly coiled. Want to know what book they got this out of. Now it has our last skin structure in it too. That there is a lamellated or Pacinian corpuscle. I've decided I do not like the term lamellated because I've seen lamellated, lamellar, laminar, all these different spellings. Pacinian, let him keep his name. What did Pacinian ever do to you? So, this is the lamellated corpuscle. It is wrapped in layers and layers and layers and layers of these cells. And it detects a crude touch. And it tends to be very deep, almost in the dermis. I mean hypodermis. So just to get an idea of the size, here's the lamellar corpuscle. There's our eccrine gland with its skin. And here's our Meissner's corpuscles. And no, this wasn't Photoshopped to bring the Meissner and the Pacinian corpuscle close to each other. I would never dream of doing such a thing. Okay, so thank you for watching our review. Have a good day.